Hello again, everyone. I'm turning now to the second part of the homework from this, starting with number 57. And if you notice right away, capital H of x, it's an accumulation function, and we're starting to accumulate at 0. So notice how the relationship between f of t and f of x. If you take the derivative of capital H, then we are going to get f of x. So for this entire problem, think of the derivative of capital H is actually f of x. Now, as we walk through these problems, keep track of capital H and then also of f of x. H of 0 means we're going to integrate from 0 to 0. So this would be equal to 0. Now, on what interval is h increasing? Well, h is starting to accumulate area under this curve from 0 until you get to 6. So when is h increasing? It's increasing from 0 to 6. Now, for an explanation, remember that h prime is actually equal to f of x. And f of x is above the x-axis. It takes on positive values from 0 to 6. Now, on what interval is the graph of h concave up? Well, h concave up, what we're looking for is h double prime to be greater than 0. So that means we're looking for when f prime is greater than 0, or when is the slope of f positive, and that would be from 9 to 12. Okay, 9 to 12, from about right here to here, you can see that it's positive. Is h of 12 positive or negative? Well, we're accumulating area above the curve. Then there's area below the curve, but in terms of an integral, positive, and this is negative. We can see that this area is larger than this. So even though this is negative, it's not enough to cancel this out. So is h of 12 positive or negative? It's going to be positive. Now, where does h achieve its maximum value? Well, it's accumulating area here. Then the value of the integral is negative here. This is going to eat into some of this, cancel some of it out. But in terms of the largest, that would be right at 6. So this is at 6. Now, if we go back to earlier in our discussions of the way f operates, is notice that it goes from positive to 0 to negative, and f is the derivative of h prime. So that means h prime is taking positive values, then 0, then negative. So when does it achieve a maximum value? At 6. Now, when does it achieve its minimum value? Well, if we go from 0 to 0, okay, 0 to 0, it's going to have a minimum value of 0. Then it's going to collect area, reach its max. The value of this integral is negative, but this is not enough to cancel out all of this. So where does it achieve its minimum value? That would be at 0.